In this video, I'm going to give you a few more examples of system file operations and give you a little bit more detail on what's happening with each one. First, I'm going to give you a little overview of how things are set up, some reminders, and tell you where things are, which things are in storage, which things are in memory. And then I'm going to give you an example use case, or a few example use cases for these operations that you can do on files. So on storage, you're going to have your boot block. This is going to tell the OS actually how to load in your file system. And then the volume control block, there's one per volume, and it's going to tell, it's a bunch of metadata basically. So it has metadata on number of blocks that are used, so on and so forth. And then the directory structure is also going to be on storage, and this is how your file system looks. So we'll talk about directory structure, directory implementation in the next video. And so this is what's going to be stored on storage. And it's going to basically tell how things are organized, where your files are. And then your file control blocks and files themselves are all going to be also on storage. In memory, you're going to have your mount table. That's going to give you, idea of which volumes are mounted. Has to be in memory if it's being used. The second thing is any cached directories. So in the course of looking through directories, you might want to cache some of the directories that are being commonly used, so you don't have to go back into storage every time when you need to search that directory. Also in memory is the system-wide open file table. This tells you all the files that are open in the system at a given time. The per process open file table. So each process has its own open file table. That all needs to be in memory too. And then buffers for reading in data. So some example use cases. So one example use case is creating a file. So here, creating a file, the first thing that you want to do is you want to allocate a new file control block. And so file control block kind of looks something like this. Where you have a bunch of different attributes. So we had a process control block, we had a thread control block, and this is just the file equivalent of it. So it's going to hold some metadata like permissions, dates of creation, owner, groups, file size, and then the data blocks are pointers to the data blocks of where it's actually sitting in storage. In addition, so Linux, it should be of note that Linux also has a type that they keep track of here too, and this type, the reason it's there is because Linux treats directories like files, and so to distinguish between a file and a directory, it has this type. And so if you do an ls-l, you'll actually see a D at the front of all of your folders, and this is telling you that it's actually a directory. So two different ways that you can allocate a new file control block. You can create a brand new one, or you can use a pre-allocated one. So some OSs do it in different ways. Some don't pre-allocate any file control blocks. Others pre-allocate, n number of them, and then you can just use one of those pre-allocated ones. So then the second thing that you want to do is you want to read the directory into memory. So wherever this file is going, you need to read that directory into memory, because anytime you need to modify the directory, that needs to be read into memory. You want to update it, and then you want to write it back to the disk. Our second use case is opening a file. So this is opening a file via the open system call. So the first thing that you're going to do is you're going to look at the open file table. So the system-wide open file table, you want to look to see if the file is actually open. So in this process, we call this openf function. So the first thing that we want to do is we want to look into the system-wide open files table and see if it's there. It is there, so maybe it's already being used by another process, so it's there. Great. So now what we would do is we would create an entry in the per process open file table, and then point this to the system wide. So I'm going to erase this for now. Okay, so now we have this pointer. This pointer is going to be really important, and I'll show you its use in some other examples. So that's if it's found. So now let's look and see if it's not found. So if we are calling the open system call again and we look, so we run it open, if it's not found, so say in here, this does not exist, this does not exist yet. So the first thing that we want to do is we want to search. So we want to go to our directory, we want to search and find the file that we want to open. Then we want to copy its file control block into our system-wide open file. So I want to copy FCB, and then we'll record that one process is using it. And now we can go ahead and we can add our entry into our per process, and we add this link. Okay, so that's opening a file if it's not found. So then the last thing that happens when you open a file is that open actually returns a pointer to the entry in the per process open file table, and now any other operations you do to that file will be done via this pointer. Okay, so let's talk about closing a file. So now we have this process that is called the close F function. And so now, close function on F rather. So now what we need to do is, the first thing that we do is we can get rid of this entry in the per process open file. But we should be very careful about actually keeping this link here, so we need to save the pointer somehow, because we need to follow it to get to the system-wide open file. So the next thing that we do in the system-wide open file is we decrement this count. So this is the count of the number of processes that are using it. If this drops to 0, we know that no processes are using it, so it's safe to close this file and to remove this from the system-wide open file. So the next thing that we want to do is we actually want to copy the contents of F's control block back into the directory, because it may have changed, it may have gotten larger, it may have been renamed, so on and so forth. So we want to copy the changes back in. The fourth thing that we can do is we can finally remove. Okay, so let's look at that again, but this time notice that we have another process that might be using this F. Right, so we have a count of 2 here. That means another process is using the same file. So let's go over that again. So the first thing, so a process calls close. We want to get rid of this. We want to keep this pointer, move over here, and now we want to decrement this to 1, but now it's not 0. So we don't actually copy anything back to the directory, and we don't get rid of it in the system-wide open files. So it's a little bit different. You have to keep in mind what other processes are running, and if they may have that file open, because if you get rid of it in the system-wide open files, then there's going to be issue in actually when you close the file from the other process, it's going to look to want to write this back, but it's not going to be able to. So let me know if you have any questions. Next, we will talk about directory implementation.